Good morning, students. Today we are going to see collision. So what is collision? When two bodies come very close to each other, there happens exchange of either velocity or momenta and energy. So when two bodies are approaching very close to each other, a force comes into picture between them for a finite time and brings about a measurable change. There happens a change in either in velocity, momenta and energy. According to the respective laws of conservation, a collision is said to have taken place. In other words, when two bodies, both this is moving in positive x direction and this is the second body which is moving in negative x axis, what will happen? They come very close to each other like this. During this process, either there will be exchange of velocity will happen, momentum will happen, or there will be change in energy also can happen. So according to the respective laws of conservation, a collision is said to have taken place. So what are the different types of collision? There are two types of collision. One is elastic collision and one is inelastic collision. Let us see each collision in details. Here one more term is there. One is collision and second is scattering. And this scattering is also same process, but in that the only difference between these two is the nature of the particle after the collision will not change at all. It will remain the same. So the collision is termed scattering if the nature of the particle does not change after collision. Elastic scattering or elastic collision. A collision is said to have elastic collision if the final particles after collision are the same as the initial particle before the collision. Means after the collision, the particle will retain its size and shape. There will no exchange of energy or velocity will take place. Such type of collision is called as elastic collision. The example of this is billiard game. In billiard game, there is a rectangle table and a number of small balls are there, and with the help of stick we will collide one ball with another so that it can fall in the respective holes given at the corner of the rectangular table. So that is all about the billiard. In that there is no exchange of energy or velocity takes place. So the particles, or here is the ball, before the collision and after the collision it will remain the same. So such type of collision is called as elastic collision. Second important thing that we need to see remember is that the sum of the kinetic energy of the particles after the collision is the sum of the kinetic energy of the particle before collision. So here two things are there. The final particle after collision are the same as the initial particle before collision, and second point is the sum of the kinetic energies of the particle after collision is the same as the sum of the kinetic energies of the particle before collision. Now let us see the inelastic collision. A collision is said to be an inelastic collision if the final particle after collision are the same as the initial particle before collision, but the sum of the kinetic energy of the particle after collision is either more or less than the sum of kinetic energy of the particle before collision. So it can be, the kinetic energy can be either more or less depend upon the condition, but it is not always the same. It is different. So these are the two important parameters that decide whether the collision is elastic or inelastic in nature. A collision is said to be perfectly inelastic if the particles stick permanently together on impact and laws of kinetic energy is maximum consistent with the law of conservation of momentum. The collision can be said as perfectly inelastic if the particle will stick after the collision, and the laws of kinetic, here the kinetic energy will come to after sticking with another particle, the first particle will lose its all energy, kinetic energy. So lose the kinetic energy is maximum consistent with the law of conservation of momentum. Now we will see what are the conserved things. First is the conservation of linear momentum and second is conservation of kinetic energy. So first is the conservation of linear momentum. We will consider two particles, one of mass m1, let this be mass of m1 and this be mass of m2. m2 moving with velocities. This is moving with u1 and this is moving with u2 respectively before collision in an inertial frame of reference. After collision, now after a certain period of time, these two particles, they are colliding with each other, and afterwards the initial velocity, which is u1, will change into final velocity, that is v1 for the first particle, and v2 will be the second particle's velocity. After collision, their velocities become v1 and v2 respectively. When no external force act on the particle, their total linear momentum is conserved. Means linear momentum is mass into velocity term. So the first particle, its mass is m1, it is having velocity u1, plus m2 is the mass of second particle and moving with velocity u2 before collision, which is equal to m1 v1 plus m2 v2. This is velocity they acquired after the collision. This result hold good both for elastic as well as in an inelastic collision. Whether the collision has happened elastic nature or whether it is inelastic, this is true for both the cases. That is, linear momentum is conserved. Now let us see the conservation of kinetic energy. In case of elastic collision, the kinetic energy is also conserved. We know that kinetic energy is given by half m velocity square. So for the first particle, it is half m1 u1 square plus half m2 u2 square, which is equal to half m1 v1 square plus half m2 v2 square. Examples of elastic collisions are collision between molecule of gases according to kinetic theory of gases, then collision between atoms and nuclei. Third is collision between particles like electrons, protons, alpha particles, etc. These are examples of elastic collision. And inelastic collision is whatever collision happens in our day-to-day life. In the most famous examples are the road accidents. These collisions comes under inelastic category. Before moving into the derivation of collision, first let us understand certain terms. First is, a reference frame is the space determined by the rigid body regarded as the base. First is the reference frame. So we consider any rigid body. Let this be a rigid body. It should be rigid, and the space determined, it is in some certain space. So that is the reference frame of this rigid body. A rigid body is supposed to extend in all directions as far as necessary. Now, a point in space is located by three coordinates. As we all know that if we are considering three-dimensional space and this is a certain point P, then its position is determined by X, Y and Z. So, a point in space is located by the three coordinates taken with respect to the origin. With respect to the origin, we will consider with respect to the origin of the reference system. If the origin of the reference system is a point rigidly fixed to a laboratory, it is known as laboratory frame. Means if the origin of the reference frame is a point rigidly fixed in the laboratory, any certain laboratory is there, and if its origin is fixed in that, then it is called as laboratory frame. And if the origin of the reference system is a point rigidly fixed to the center of mass of a system of particles on which no external force is acting, it is known as center of mass frame. So there are two frames. One is laboratory frame and second is center of mass frame. So for both the things, the derivations are different, entirely different. Exchange of energy is totally different. So we will see one by one. The laboratory frame is inertial so long as Earth is taken to be inertial frame. We consider our Earth system as inertial frame. So the laboratory frame is inertial so long we consider our Earth as an inertial frame. Elastic collision, we will see. A collision is said to be elastic if first the final particle after the collision are the same as the initial particle before collision, and second the momentum and energy both are conserved. These are the two important parameters that we should remember while deriving the expression. Perfectly elastic collision in laboratory frame. We are going to see laboratory frame, that is in the earth system. Any collision which is elastic in nature and that happens on the surface of the earth is for that we are going to derive. Let we consider two particles, one with mass m1 and second with mass m2, be the masses of the two particles that we considered, which are going to collide with each other, and u1 is the initial velocity of mass m1 and u2 is the initial velocity of mass m2, and after collision v1 and v2 are the velocities of first mass m1 and second mass m2 respectively. Before and after collision, an elastic one-dimensional collision, that is a head-on collision we are considering in this case along the line joining their centers. Here we are considering very important thing is line joining the center. This is the center and this is the second particle having center. Let this is m1, this is m2, it is moving with velocity u1, this is velocity with u2, and this is moving in this direction and this is moving in this direction. According to principle of conservation of linear momentum, we will start writing according to the principle of conservation of linear momentum, m1u1 plus m2u2 sum of momentum before collision is equal to sum of momentum after the collision, that is m1 v1 bar plus m2 v2 bar, equation 1. Now according to the law of conservation of energy, m1 u1 square plus, this is the kinetic energy, this is half m1 u1 square plus half m2 u2 square is equal to half m1 v1 square plus half m2 v2 square. We will cancel half from entire equation, so equation becomes m1 u1 square plus m2 u2 square is equal to m1 v1 square plus m2 v2 square. This is equation number 2. Now we will rewrite equation 1 and 2, and we will consider only the magnitude, taking magnitude only. We have m1 u1, we will consider magnitude means m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. We will collect m1 terms over here, u1 minus m1 v1 is equal to m2 v2 minus m2 u2. From this equation we will get m1 common, u1 minus v1 is equal to m2 v2 minus u2. This is equation number 3. And similarly from equation 2, m1 u1 square minus m1 v1 square. I will not skip the steps. Let m1 u1 square plus m2 u2 square is equal to m1 v1 square plus m2 v2 square. m1 u1 square minus m1 v1 square is equal to m2 v2 square minus m2 u2 square. m1 common, u1 square minus v1 square is equal to m2 v2 square minus u2 square. Equation number 4. Now we will divide equation 4 by 5, we get m1 u1 square minus v1 square upon m1 u1 minus v1 is equal to m2 v2 square minus u2 square divided by m2 v2 minus u2. m1 m1 I will again do u1 square minus v1 square upon m1 u1 minus v1 is equal to m2 v2 square minus u2 square upon m2 v2 minus u2. m1 m1 m2 m2 will get cancelled. u1 minus v1 u1 plus v1 divided by u1 minus v1 is equal to v2 minus u2 v2 plus u2 upon v2 minus u2. This will get cancelled. So u1 plus v1 is equal to, we can say, u2 plus v2. Again rearranging, we will get u1 minus u2 is equal to v2 minus v1, or this can be u1 minus u2 is equal to minus v1 minus v2. This is very important statement. This is equation number 5. So equation 5 shows that in an elastic one-dimensional collision, the relative velocity with which the two particles approach each other, this is the relative velocities, is equal to relative velocity with which they reside. After they will reside away from each other, means negative sign shows that they will reside away from each other after collision. Now we will determine the velocity. So velocity after collision we will determine, that is the value of v1 and v2 we will try to find. So velocity after collision, very important, from equation 5. This equation we can write v1, if we take to this side, so this becomes v2, v1 goes to this side and this will go to this side, means v2 minus u1 plus u2, and v2 similarly, or in this equation only we will modify, v2 is equal to v1 plus u1 minus u2, substituting the value of v2 in equation 3. Substituting the value of v2 in equation 3, we have, this is our equation 3, u1 minus v1 is equal to m2 v2 minus u2. This can be written as m1 u1 minus v1. In place of, we are determining v1, so m2, in place of v2 we will substitute this value, v1 plus u1 minus u2 minus u2. m1 u1 minus v1 is equal to m2 v1 minus u1 minus 2 u2. So m1 u1 minus m1 v1 is equal to m2 v1 m2, this is plus m2 u1 minus 2 m2 u2. Now we will collect v1, we will take v1 to this side, minus m1 v1 minus m2 v1 is equal to m2 u1 minus 2 m2 u2 minus m1 u1. We will take minus v1 common, m1 plus m2 is equal to m2 u1 minus m1 u1 minus 2 m2 u2 minus v1, m1 plus m2 is equal to u1, we will take common, m2 minus m1 minus 2 m2 u2. Now multiply throughout by -1, we will get V1 M1 plus M2 is equal to U1 minus M2 plus M1 plus 2 M2 U2. V1 M1 plus M2 is equal to U1 M1, we will write first, then minus M2 plus 2 M2 U2. From this equation we will take this to the denominator, so equation get modified as U1 M1 minus M2 upon M1 plus M2 plus 2 M2 upon M1 plus M2 into U2. So this is our final result of velocity of the first particle after collision. Similarly, for velocity of the second particle with velocity v2, straightforward, only change 1 by, for the masses, 1 by 2. 1 by, not for masses, for entire thing, interchange 1 by 2. So equation become u2 m2 minus m1 upon, it will remain same since this is sum, so it will remain same, plus 2 times m1 upon m1 plus m2 times u1. This is final velocity. Now we will see the cases. Case 1, special cases. Special cases. If m1 is equal to m2, then what will happen? If mass becomes same, so this will be 0, we will be remain with this, so this is 2m2 upon again 2m2, this will cancel, we are remaining with u2 only. Substitute in this equation, we will get v1 is equal to u2 bar. Similarly, this becomes, since this is 0 term, 2 times m1, in place of m1 we will substitute m2, so 2 times m2 upon m2 plus m2 means 2 times m2, 2m2 2m2 will get cancel, so we will be remaining with u1 term, that is v2 bar is equal to u1 bar. Thus, in perfectly elastic collision of two bodies of equal mass in one dimension, velocities, here you can see velocities are interchanging. Velocity v1 means the first particle will acquire velocity of second, and second particle will acquire velocity of first particle. Velocities are simply interchanged. Now case 2. This was case 1. Case 2. If u2 is equal to 0, means the second particle is at rest, so velocity v1 will become just in this, put u2 is equal to 0 in this two equations, so we are remaining with this 2. v1 m1 minus m2 upon m1 plus m2 u1 bar, and v2 bar is equal to 2 times u2 becomes 0 in this equation, so this term will remain, so 2 times m1 upon m1 plus m2 u1 bar. Now we will consider case 3. u2, the second particle is at rest, and the mass of second particle is much greater than mass of first particle. In this equation, mass of second particle is much greater than this, means this will become, we can consider it as 0, so we will remaining with the m2 term, m2 will get cancelled, only minus term will be there. This So, and u2 is 0. u2 means this entire term is 0. So this will be v1 is equal to minus u1. So we can write v1 is equal to minus u1 bar. NEARLY. And in this case u2 is 0 means this entire term is 0, and m2 is much greater than m1 means if we can neglect if this is 1, so 1 upon some greater number will gives you 0, so this is literally 0. So v2 will become v2 is equal to 0 nearly. Thus, when a light particle collides with massive particle at rest, the heavy particle continues to remain at rest and velocity of the first particle is reverse. This is the example of a car or a bike colliding with a heavy truck. The truck will remain at the same place, whereas the velocity of the motorbike will get reversed and it will fall in some other place, whereas the truck will remain at the same place. This is example. So thus, when the light particle collides the massive particle at rest, the heavy particle continues to remain at rest and the velocity of the particle which is colliding with the heavy will get reverse. On the other hand, if u2 bar is equal to 0 and m1 is much greater than m2, in that case v1 will be equal to u1 and v2 is equal to 2 times u1. Hence, when a heavy particle, for example our truck, is colliding with a bike, what will happen? The heavy truck continues in the same speed after collision. It will nothing happen to the truck, whereas the light particle, here in our case is the bike, it will acquire twice the velocity of the heavy truck and ultimately it will get deformed. So this is what these are the examples of our day-to-day life which happens in our road. Hence, when heavy particle collide the light particle after rest, then the heavy particle continue with the same speed after collision, but light particle acquire nearly. Now we will see elastic collision in center of mass frame. For that, let m1 and m2 be the masses of two particles moving with velocities u1 and u2 after collision. v1 and v2 be its final velocities. Here very important, it is happening in the center of mass frame. So relative to the center of mass frame, when no external force is acting, the velocity of center of mass relative to the laboratory frame of reference, that is, here we will consider m2 is at rest. So when m2 is rest means its velocity is 0. We denoted velocity of mass m2 by u2, hence u2 is equal to 0. So we can write velocity VCM, velocity of center of mass, is equal to m1 u1 divided by m1 plus m2, equation number 1. Since In elastic collision, the velocity of center of mass V bar remains constant even after collision. Now we will consider Galilean transformation. According to Galilean transformation, the velocities of particles relative to center of mass before collision are given by u1 bar dash, this is after collision, u1 minus vcm, velocity, initial velocity of first particle minus velocity of center of mass. Similarly, after collision, u2 bar is equal to u2 bar minus vcm. But we know that the second particle is at rest, means u2 is equal to 0. So simply this equation become v bar cm. Since we can write, reason is u2 is equal to 0. After the collision, velocities are v1 dash bar is equal to v1 minus vcm, and similarly v2 bar dash is equal to v2 minus vcm. But at the same time, we know that the total linear momentum of the system in center of mass frame is also 0. So we will write here, but total linear momentum of the system in the center of mass frame remains 0. Therefore, momentum before collision, that is mass of first particle plus mass of momentum into mass into momentum of second particle, that is mass into velocity of the second particle, which is equal to 0. From this we can conclude that m1 u1 dash is equal to minus m2 u2 dash. Similarly, we will write for after collision. After collision, momentum is m1 v1 dash bar plus m2 v2 dash bar is equal to 0. m1 v1 dash is equal to minus m2 v2 dash. Now, law of conservation we will use. We will consider only the taking the magnitude of the previous equation. Taking the magnitudes only. We will only consider magnitude. So now for law of conservation, we will get m1 u1 dash is equal to m2 u2 dash, and m1 v1 dash is equal to m2 v2 dash. And kinetic energy we can write, this is for the momentum, and the kinetic energy we will write, we know that half m1 u1 dash square plus half m2 u2 dash square is equal to half m1 v1 dash square plus half m2 v2 dash square. Now we will put from this equation u1 and m1, u1 and m2, putting for u2 dash and v2 dash in above equation, means u2 dash as well as v2 dash. From this equation, u2 dash is equal to m1 u1 dash upon m2 and v2 dash is equal to m1 v1 dash upon m2. When we substitute, we will get half m1 u1 dash square plus half m2 m1 u1 dash upon m2 the whole square is equal to half m1 v1 dash square plus half m2 m1 upon m2 v1 dash the whole square. We will cancel half from entire equation, so we will be remaining with m1 u1 dash square plus m2 m1 square u1 dash square upon m2 square m1 square upon m2 is equal to m1 v1 dash square plus m2 m1 square upon m2 square v1 dash the whole square. m2 will get cancelled. Now we will take common m1 u1 square, m1 u1 dash square, so from here 1 plus here m1 got cancelled, so m1 upon m2 will be remaining. Similarly, m1 v1 dash square, we will take 1 plus m1 because this is extra upon m2, so this will also get cancelled, so m1 will also get cancelled. u1 dash square is equal to v1 dash square, so u1 dash is equal to v1 dash. Similarly, when we solve, there is no need to derive the entire thing for the second term. Similarly, you can write similarly u2 dash is equal to v2 dash. These are the center of mass, frame of reference. The magnitude of velocity of each particle remains unchanged. u1 will acquire v1 and u2 will go to v2, unchanged in the elastic collision. Thank you.